Hi guys, BuildZoid here, and today we're going to be taking a look at the RX 5700 XT Gigabyte gaming card. So, yeah, and the thing is, this is a pretty standard, like, arguably downcosted RX 5700 XT PCB. But, so, as far as the actual, like, voltage, like, as far as the power stages are concerned, this really isn't anything that special. But what I'm really interested in is the capacitor configuration on this card, because it's one of the this has a, for what it is. It's like, I'm surprised Gigabyte like has redesigned it as much as they have. So yeah, let's get right into it. So the standard stuff is, of course, the V-Core VRM, which is right over here. Right, so that's our V-Core. And that's a 1, 2, 3, 4, 5, 6, 7 phase. We've never seen that before on an RX 570. I mean RX 5700 XT, right? That's totally unique and special right there. Then down here we have what I assume is the VSOC rail, which is, of course, is just a single phase. Then we have the split two-phase memory VRM up here, which is the VMEM. So that's our VMEM. And then we of course have this regulator over here, which is which is what I assume is the VDDCI, which is the power for the memory controller. And that's another single phase, right? So we've got 1, 2 there. So it's the usual 7 plus 2, 7 plus 1 plus 2 plus 1 VRM configuration of an RX 5700 XT. And for the controllers, if we go on the back of the card, we've got a IR35, IR35217. And that's the controller handling the V-Core and the SoC rail, or the suspected SoC rail. That's a 7+1. That's running in a 7+1 configuration. This is the standard high-end voltage controller you see on modern AMD GPUs. It's been in use since the Vega Frontier Edition. Yeah, not really much else to say about it. There's no public data sheet for it, unfortunately, which is kind of annoying, like, at all. Like, you can't even get a pinout for this thing. You can't even actually find a product listing for it on International Rectifier's own website, which is just like, that's great. Yeah. It's not unusual for that to be the case. Like, there's a lot of situations where it's like, oh yeah, this controller, who makes it? Like, it's evidently an IR part, and then you try to look it up, and it's just like IR doesn't like. I guess unless you're a manufacturer, it's just like IR doesn't care that you can't get any info about it. Anyway, so yeah, standard 7+1 phase setup on that. It's fully digital. It's really, like, it's a high-end voltage controller, but that's pretty standard for AMD AMD GPUs, and it's fine that I scribbled on that layer. Anyway, so that's handling the V-Core. Then for the VDDCI and the VMEM, we of course have the NCP81022. That's running in as a 2+1 configuration. This does have a public data sheet. It is very easy to mod, so if you want to mess around with your VMEM or your VDDCI rail, you just need to look up the data sheet, and you can mod away. The only real concerns with this is, well, VMEM, like, I don't think you'll see any performance scaling from messing with VMEM, because I assume that the thing that's restricting memory overclocking on RX 5700 XTs is AMD's memory controller, not the GDDR6 itself, because, NVIDIA uses the exact same GDDR6 chips, and their cards clock them way higher than AMD's do. And the VDDCI rail, well, this is a rail that has a really easy time destroying GPUs if you just raise it a bit too much. So yeah, that's kind of the thing. Is just like, if you're feeling brave, you can definitely try to see if you can, get some more performance out of the memory system, but very risky. Like, especially tweaking VDDCI is very, very risky, because as much as, like, you bump this up by 200 millivolts, and you can very quickly go from having a card that works to within an hour having a card that's going to artifact for the rest of its life because you've just destroyed the memory controller. So that's kind of the thing to keep in mind with that. But anyway, so that's pretty standard for RX 5700 XTs in terms of the controllers. In the V-Core VRM, the power stages, and actually the power stages everywhere on this card, are SiC 620As from Vishay Semiconductor. These are 60 amp parts, so that's pretty nice. So 60 amp power stages, they're not smart, they're dumb. So the current monitoring has to be done externally, but they are plenty efficient, and they don't even have like internal temperature monitoring either. So there's going to be, I assume that's the temperature monitoring in the VRM. Like that right there is probably a thermistor for monitoring the VRM temperature, because yeah, the power stages don't integrate that. They do have a signal line to tell the VRM, hey, I'm overheating, but they don't actually have like a temperature monitoring line. It's just kind of like just a thermal flag, basically, not a thermal readout, right? Like the difference being one is either on or off. So if the flag, like I don't remember which way it works with the flag for these, but basically the power stages will either tell the control, like one of the power, like if it's overheating, the power stages can tell the VRM we're overheating, but the controller, but they can't tell the controller like, hey, I'm at a specific temperature, because there's no functionality for that. So anyway, still, they're 60 amp parts, so they're plenty efficient. And really, this is kind of the same vCore VRM configuration that you'd see on a Sapphire Pulse. In terms of efficiency, we're looking at the following figures for 1.2 volts output, 400 kilohertz switching frequency. Oh, wait, not 400, 500. And 5 volts drive. These don't run on anything but 5 volts, so that's why we're going with 5 volts drive. You're going to be looking at 150 amps output, producing about 15 watts of heat, which is completely standard for a RX 5700 XT PCB. That's pretty normal. 200 amps output. This lags a little bit behind the reference PCB for a 5700 XT, because of course it does. The 5700 XT reference PCB uses a bunch of 70 amp smart power stages from Fairchild, which is owned by On Semiconductor. So the thing is just like, yeah, like most RX 5700 XTs, the power stages are slightly downgraded from the reference PCB. Because for like AMD really likes expensive reference cards. So, but manufacturers making, other manufacturers making cards, yeah, they don't really like spending money on things like tantalum capacitors for the input filter, the SMD polymers for the output filter, or the 70 amp smart power stages, when you can get, because the thing is, the 70 amp smart power stages, I'm not sure how much the actual manufacturers pay for them, because that's like, if you look at third-party websites, the prices you see are a lot of the time very different from what the manufacturers pay, because they'll often be buying directly from the manufacturer, like from the actual, like, so the GPU manufacturers will actually be buying directly from the power stage manufacturers, and they skip the third party that you would have to go through normally if you're just looking at like public price listings. And so it can get some pretty deep discounts as a result of that. But even then, it's like, if something is, $5 at a third party and something is $1 at a third party, then it's just like, there's probably going to be a similar sort of difference for the actual GPU manufacturers. So, these are like $1, and the 70 amp smart power stages are like $2. So these are probably like half $1 for Gigabyte, and Sapphire also uses them. So Sapphire, Gigabyte, they're probably going to be paying like half $1 for these, whereas for the smart power stages, they could be paying twice as much. So it makes sense that they're not going to use the 70 amp smart power stages. So, anyway, and that's why basically all of the reference RX 5700 XTs have some of the have one of the nicest PCBs, because nobody actually wants to pay the top, like the price that AMD is willing to pay for the power stages. Anyway, going up to 250 amps output, the VRM will be producing about 32 watts of heat, and doing about 300 amps output, the VRM will produce about 44. And then at 350 amps output, the VRM would produce about 61 watts of heat. Now, I've not had an RX 5700 XT in my hands. I don't plan to get a 5700 XT anytime soon, just because I am way too busy with testing with motherboards and RAM and just that kind of thing. And what's worse? There's more motherboards coming. Yeah, if Intel and AMD could just lay off the releases for a while, that would be great. Drowning in work. But anyway, so I'm probably not going to see a 5700 XT for a while. The other thing is, it's just I don't really I prefer overclocking old GPUs. Anyway, it's like the best GPU ever made is the 7970. The second best GPU is the 290X, and everything else sucks. Actually, no. Things older than like 5870s are fun. I've not messed with a single 6000 series though, which I'm kind of like I need to get my I need to get my hands at least on a 6990 because that's a dual core, and I'm a like I have a thing for collecting dual core cards, but anyway, like right now, like it's not a priority right now because as I said, I'm just way behind on the motherboards and RAM and CPUs and too much, way too much. Anyway, a 5700 XT will probably run in this range. I just don't know for sure. That's what my whole point was with the whole I've not yet had a 5700 XT in my hands. But yeah, the VCore VRM really shouldn't be exceeding this range if you're on ambient cooling. Actually, I'd be surprised if you get to 250 amps on ambient because that would put you at around 300 watts for the core. And I would assume the memory system on this thing probably pulls somewhere around 30 watts. I'm assuming, like, I'm not sure. Like, again, if I had one, I could try measure it, but I don't have one, so I'm not 100% certain. But yeah, I'd assume somewhere around 30 watts for the memory system. So, you know, you'd be looking at a car like a 400 watt 5700 XT, right? Like the total power the whole card would pull would be somewhere in the 400 watt range. And I mean, that's not impossible to do. Like, well, but the thing, well, no, a 5700 XT, that may very well be impossible for one of these to hit. So that's kind of the thing to keep in mind is just like, yeah, I don't really think you're going to hit 250 amps unless you're on like Sub-Zero or something. In which case, you know, the benchmarks, like I think the longest benchmark people run is 3D Mark Vantage. Now I think a Unigine superposition might also be pretty long because I know Heaven is long. Heaven was like 4 minutes, but 3D Mark Vantage is around 4 minutes as well. And so the point is the VRM has to not overheat for 4 minutes. 4 minutes is not a very long time in VR in terms of VRM thermals. So yeah, this honestly should never really be a concern, right? Especially if you're on ambient or if you're on the stock cooling system of this card, like it has a lot of airflow and a good amount of surface area over the VRM itself. So I really wouldn't be concerned about it. Yeah, you can get higher efficiencies at 250 amps output, but the thing is, unlike motherboards, GPUs really do have a huge cooling advantage. Like, motherboard VRMs are in this awkward location where like it's a total airflow dead zone normally, especially if you're running an AIO, there's just no airflow in that area. Whereas on GPUs, I mean, there is a fan pointed straight at the PCB on, you know, basically all GPUs these days. So yeah, and that just makes a huge that's a huge advantage for cooling the VRM. So that's why, you know, GPUs don't necessarily need to be the most efficient even at the higher current outputs compared to like motherboards where it's just like, yeah, if it's not super efficient then it's going to overheat because normally there's just nothing to cool it properly there. Anyway, so yeah, this is pretty standard for a 5700 XT PCB, nothing really special there, so I wouldn't worry about it. And this right here is just like where the data sheet stops. That's the only reason why we go up to that value. It's not really a practical value. I don't think you'd ever get a 5700 XT to do that, even if you were on liquid nitrogen, because the thing is with liquid nitrogen, you actually, like for any given voltage, if you're on liquid nitrogen, you're actually going to pull less power. Except like there are exceptions to that where like you can take well, say NVIDIA GPUs especially, like when you put them on liquid nitrogen, they scale to so much higher voltages and so much higher frequencies that you can very easily take a card that, you know, say on ambient cooling is around 300 watts to about 600 watts on liquid nitrogen. But it's still not like you're going from, like on ambient, you might be pushing 250 amps, and then on liquid nitrogen you actually crank up the voltage really high, so you end up at like say 1.5 volts. So the current increase isn't really as high as you would think it would be. It's not like you double the current draw, you maybe increase it by 50%. So compared to ambient. Anyway, yeah, that's it for the VRM on this. So really nothing, you know, it's not bad. It's definitely not the worst VRM you can get on a 5700 XT. It's also not the best, right? Like, because again, it's one of the the downcosted alternative sort of reference. Well, it's not even like most of the other cards look like a like the thing is like this is the thing that I find interesting with this card is just Gigabyte did use it's still a 7+1 phase configuration for the V-Core and the SoC, but a lot of the other cards when you look at their when you look at the actual PCB, they just look like the Sapphire Pulse card. Like literally, I think the ASRock Challenger is same PCB as the Sapphire Pulse. The Evoke is the same PCB as in like well, no, Evoke is slightly tweaked, but it's basically the same layout. The Power Color Dual Fan card again is like basically the same PCB as the Evoke as the Pulse. And the XFX thick is also again like the same PCB. Now some of them have like small extensions, like the PCB is a bit longer or shorter or something like that, but capacitor configuration, power stage, like VRM layout, everything is just like the important stuff is the same, right? But then we have Gigabyte, where also again it's very similar in terms of the like same footprint power stages. So you could actually take this and swap in like the 55 amp NCP 302155s. Or, you know, so there's some, like, this isn't that far off from what a lot of the other cards run, but what I find interesting about this card is the actual capacitor configuration, because if we look at, say, like, the back of the card is where it's most obvious, is we have these, so we have the SMD polymers right there, or at least I assume they're polymers, because if they were tantalums, I would expect this to be a much paler stripe over there, or they'd be yellow. Though generally you don't see, like the yellow, the funny thing about yellow tantalums is that, as far as I know, that's like Chemet packaging, and the yellow ones from Chemet specifically are like automotive grade and insanely expensive as a result, because, and they don't make sense on a GPU, because you can actually get tantalums with similar performance metrics, similar endurance, much cheaper if you just buy them in the black packaging, which isn't like the automotive grade ones have, I think, might be higher temperature tolerance, or like there's something specific about them that is like, yeah, these are for cars versus general use tantalums. So anyways, these don't look like tantalums. These are almost certainly aluminum polymers. They're actually really kind of like, that's 560 microfarads on there. Which is really quite high. Like you don't really, that's kind of the upper limit for this packaging. If you're looking at polymers, you can get tantalums in 1,000 microfarads in this same size. Well, they're kind of tall, but still you can get basically twice this. So yeah, this is kind of interesting because you don't really see this on any of the other cards. Basically all of the other cards look like this. Right, this is where I need the extra layers. Bam. So basically all of the other cards, you'll actually see something that looks like this. And this is true even for, say, like the Power Color Red Devil PCB, where they, you know, they extend they actually go up to a 10-phase V-core. But what they do is they actually just copy paste the output filtering section. So like this part, they just take that and just add 3 more of them, right? Again, and it's just like, okay, so that's a thing. And then with a lot of the cards, like you'll see that, so these pictures specifically here are from the actual Pulse PCB. And you'll see that, you know, like not all of the multi-layer ceramics are fully populated here. So you just have this, and then, yeah, you have these rows of multi-layer ceramics. Those aren't fully populated, except I think Power Color does fully populate them, but most of the other manufacturers don't bother. Reason being, capacitors cost money, and if you don't need them, you don't need them, right? If the card runs at stock, that's as many capacitors as you need. So yeah, most of the cards will actually not fully populate those capacitor rows, and then you'll just have one more multi-layer ceramic sort of right here. And what I find interesting is like Gigabyte has totally redesigned their output filter. Like we kind of still get the per phase rows, and they're not fully populated as with a lot of the other cards, but they've also added these large multi-layer ceramics in between that, which is just like, okay, that's new. I'm very surprised by that. Then we, of course, have the polymers here, which is just like, okay, this might actually be kind of excessive. I'm not sure. Like, this is the kind of thing is like, I wonder, why? Like, my question really is why? Because this is the kind of thing that, like, I approve of this. I'm totally cool with them doing this, but it's just like, does this actually lead to the card? I don't know, maybe on average it would clock 10 megahertz higher? Like, that would be my guess based on the fact that these are 560s and like SMDs. They don't seem to be, yeah, they're just 2-terminal, not 3-terminal. So that's the thing, is just like with 4 of these, you know, I would guess 10, maybe 20 megahertz higher core overclocking, but it's just like, but at the same time, my experience, that's my experience with like doing this type of modification to like a reference NVIDIA card, where reference NVIDIA cards are typically built to the absolute bare minimum of what would be acceptable, except up until like the 10 series. So yeah, this is kind of like, this is really interesting in my opinion to me, because it's like they've kept like everything else about this PCB is like pretty standard for like a lower cost 5700 XT, but then we have this on the back, and it's just like, why? Why? Who does like? I mean, it's cool, but why? And then on the front, we actually see also a pretty major difference compared to the reference card, where, well, the alternative reference, where, so this is again off the pulse, right, where you see the like, that's the output filter, and you just have 1, 2, 3, 4, 5, 6, 7 bulk capacitors. These are all APAC, which I don't really care that much about who actually make. Like with polymers, I really don't care that much who makes them, because like the claim to fame of the polymer capacitor is that they're really hard to screw up. The main issue with them is that you can't get them in high voltage ratings, but it's just like they're inherently just more robust than the liquid electrolyte type capacitors, so it matters a lot less who manufactures them, right? Which is like APAC is a Taiwanese manufacturer, whereas like what Gigabyte opted for is a bunch of Nichicon FP 5K series capacitors, and that's obviously like Nichicon's a Japanese capacitor maker, and yeah, these cost more. Again, like the Gigabyte's going for more expensive output filtering, and interestingly enough, again, they have like the funny thing is like, yeah, these 2 capacitors are missing, but if you actually look at how many capacitors are on here, 3, 4, 5, and 6, and 7. So we have the same number of like bulk through-hole capacitors, right? They're still the same capacitance. They're not like 560s or something, right? You can see 821 right there. So these are still 820 microfarads. So same capacitance as these. Arguably better manufacturer. And then Gigabyte decided, yeah, so we've basically got the same bulk capacitance and the same multi-layer, like the same number of multi-layer ceramics, I would assume, as what you would get on a reference card. And then for some reason they decided, and we want, and you know, and then they decided, yeah, we also want a bunch of like SMD polymers on the back. And it's just like, why? Like, why? Right? And it's because the rest of the card, like if this was meant to be some super extreme overclocking card, I'd get it. But this is like, I don't get it why it's here, because this is not meant to be, right? Like you have the cheaper power stages compared to the reference card. You have the just like the, yeah, it's a pretty normal, like the card doesn't even come with an insane price tag, and the bulk capacitance provided by the through-hole capacitors is already sufficient, at least if you look at the reference, like all the other cards. So that really makes me wonder, like, yeah, why are these here? Like, it's good. Right, I'm not going to complain about extra SMD polymers, because these are like awesome freaking capacitors, but why? Like that's the thing. I guess it's just, well, maybe it's bonus points with BuildZoid. That's the reason why they have these. It's just like, you know, or because yeah, it's just like if they just did what everybody else did, right? Like they'd end up with a cheaper card. Like literally, it would just be cheaper, because there'd be, like, all of these wouldn't be necessary, and large multi-layer ceramics aren't exactly the cheapest thing ever either. And multi-layer ceramics generally aren't very expensive, but once you start looking at the very larger ones, they do start getting a bit, like, they start getting up there eventually. So, like, all of those are extras. This is all extra. Then I get, like, I'm not sure why they decided to leave those out, but I guess they came to the conclusion, like, to me, this actually looks like they might have tried to tune the, like, VRM to, like, the output filter to some extent, because, like, it is so far off from what the other cards run. And it's like, maybe I don't know, there's not really any reason that they'd have to run, like, a lower switching frequency. The inductance of the inductors is the same. These are 150 nanohenries. The ones on on Gigabyte's card as well. Is R15, that's 150 nanohenries. R15, that's 150 nanohenries. So that's all the same. And it's just like, yeah, and they redesigned the output, like heavily redesigned the output filter. So it's just like, I wonder if, like, basically, like, I'd really be interested to see, like, if there's a measurable difference between the, like, if you could measure a difference with an oscilloscope on this card against some of the other cards in terms of, like, transient response, mainly just transient response, because the thing is, the ripple is just, like, the ripple is going to be taken care of by basically these capacitors alone. Like, they're going to deal with that just fine. So, yeah, it's just kind of interesting because there's nothing really else on this card that's like, yeah, it's just like I don't get it. Why does this go a step further with the output filter? It's definitely not a bad thing, and I'm a fan of it. So yeah, that's kind of interesting. Out of like the cheaper 5700 XTs, it's just like, I'd argue, like, I'm actually, like, interested if this doesn't necessarily, like, this could potentially put this card on par with some of the, like not VRM efficiency-wise, but output regulation-wise, like, I'd be interested to see if this doesn't maybe rival some of the sort of higher-end 5700 XTs. And even there, I really doubt you'd see an actual practical difference in overclocking, which is kind of like, yeah, that's the issue with GPUs, isn't it? It's just like, it's generally you'll see like plus minus 10 megahertz differences most of the time. So I don't really have high expectations for it, which is why I'm still so surprised that they're bothering, is like, because those cost money, and it's just like I don't really think they're necessary, and yet they're there. And of course, other kind of neat details on this card is like they do have LEDs to indicate if you have the power connectors plugged in, which whatever, right? There's unfortunately no dual BIOS on this, but at the same time, 5700 XTs don't really support custom BIOSes, so not really a big deal. And if you're just if you're just copying, say, a 50, like if you bought the 5700, which I wonder if that uses the same PCB as this, like because this is the 5700 XT gaming, but I wonder if the 5700 gaming, because I wouldn't be surprised if that one was missing the SMD polymers. Because, like, again, it's just like, those are expensive. What are they doing on a card like this? Yeah, if you had the 5700 and you were just flashing it up to the 5700 XT, that's a really, like, I'd consider that a really safe modification. Like, there's not really that much you can do wrong, because except maybe like doing the flash and having your power, like having a power outage or something, right? Like that's the main risk if you don't fully flash the BIOS. But if you just take a 5700 XT BIOS and flash it onto a 5700, there's very little that can really go wrong, as long as you're not taking like a really custom BIOS, which even then, like, all of the cards use the same controllers. Well, except, yeah, like basically the same controllers. Plus, I'd assume the way the controllers are actually being handled by the BIOS is like the BIOS probably doesn't specifically set anything for most of the cards. So, like I'd be careful with, say, the Strix BIOS. Like that one is not sure that you'd want to mess around with that one. But yeah, it's just like, so the lack of the BIOS switch isn't really that big a deal. And then what's also interesting is like Gigabyte did seemingly want a end of card power connector option, which is kind of neat. Like I think this would have been neat, but the issue is obviously if we look at the front of the card, the heatsink ends here, and so there's no real practical way to get these power connectors to be easy to plug in. So yeah, that's a bit of a shame. Or if they did have the power connectors here, then you'd end up with like maybe the fin stack would only go to like here, and then your cable, like, well, actually no, your cables go like that. So yeah, but the thing is, you'd basically have a fin stack that might look like this, which is just kind of weird in my opinion, right? And then also you'd like, the thing is, like, it'd be so easy to mess up the edges of the fins, and then you'd have like, it wouldn't really harm performance. It's just like it wouldn't look very nice if you had a bunch of bent fins in your heatsink because you had to plug in the power connectors, and there's the cable going around here would be a huge hazard for whatever fins there. So you'd have to probably have some kind of like shield, like basically some protection around the fins, and it would just make the whole heatsink construction much more complicated. Also, your heat pipes would have to run out like that. Yeah, it's a neat idea. It's just, I think the PCB would have to end over here to actually make that practical. Anyway, so yeah, I rather like this card, or more like I find this card interesting. And reviews for this card have been generally like the heatsink seems to work just fine. The PCB in terms of the actual power stage selection, you're not looking at anything worse than any of the other, like the Pulse or the Thick or the Evoke or the you're not looking at anything worse compared to all of those cards. So yeah, it's just kind of interesting that Gigabyte seems to have like this is like Gigabyte's not, as far as I know, they're not going to be doing like a higher end version of a 5700 XT, and so it's kind of interesting that they're like low cost 3-fan model, which admittedly that's a nice heatsink, but it's not supposed to be a super expensive 5700 XT, and yet they have nicer capacitors than a lot of the other cards at this price point. They have a significantly different output filter, which is just straight up more expensive. And it's actually noteworthy also that Gigabyte is actually using the SiC 620As everywhere. A lot of the other say the Pulse, for its memory VRM, it actually downgrades to 50 amp power stages, but I think that's mostly a sort of just parts acquisition type deal with Gigabyte, where they just have piles of the 620As, and then they're not it's just easier for them to use those everywhere on the card instead of having two separate sets of parts for one GPU. So yeah, that the fact that this uses 620As everywhere, it might actually be a cost saving measure from Gigabyte's side, even though it works out to be better than some of the other cards where you have 50 amp power stages for the memory and the VDDCI VSOC rails. So yeah, still kind of interesting. Also, are those gold-plated HDMI? Well, so the thing about gold-plated ports is basically it just makes them corrosion resistant, which in some very humid climates can actually be beneficial. So yeah, it's just kind of interesting. You'd think, I was expecting this to be exactly the same as I just thought this would be a Pulse PCB all over again. But this is one thing I noticed even when Gigabyte with Gigabyte in general, is they're kind of like Asus in this sense, where Asus absolutely will not use a reference PCB. It is they have an absolute absolutely despise reference PCBs, where even cheap Asus cards will just have a completely different PCB from everybody else. Just is why? And then we don't yeah. So I find that kind of interesting, and Gigabyte seems to do that as well. It's just not as extreme. So their PCBs, you'll note you'll get weird differences where it's interesting power connector options, and a lot of the time a very different selection of capacitors. And then obviously they swap the inductors because which I think that might just be a thing with clearances for their heat sinks or something. So yeah, because I'm pretty sure this is the same inductor they had on the 290X Wind Force. This looks a lot like that inductor. Anyway, yeah, that's it for the video about this card, and it's just it's not a well, I've already said that. So yeah, that's it for this video. So thanks for watching. Hopefully it was somewhat interesting. And yeah, if you were considering this card, then go for it, right? The main thing is it's not really any worse than any other lower cost 5700 XT, except maybe the reference card, right? Because the reference card, but the thing with the reference card is the heatsink. Just well, if you're water cooling, the reference card makes sense. If you don't want to water cool, then I think this is a really solid option as well. So yeah, anyway, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I do have a Patreon where you can support me directly. And if you don't like Patreon, there's also the AHOC Teespring, where we've got shirts, we got stickers, posters. I don't know why I say we. This is a one-man show. It's just me. But yeah, there's the AHOC Teespring, where there's, stickers, posters, shirts, that kind of thing. So if you'd like to check that out, those help out immensely with running the channel as well. There's a link to that down in the description below. So yeah, that would be awesome. And that's it for the video. So thanks for watching, and goodbye.